Hi everyone, Zach here, and welcome to the prep video for lesson 32 in this series on developing a survival game. In this prep video, we'll discuss tessellation. This video and this series have been brought to you by my Patreon sponsors. Right, let's move into our prep video. So in today's video, or today's tutorial, we'll be covering up our tessellation functions, and we'll be doing so we can add waves to our water. We'll also be doing this so that we can look at tessellation in our landscape as well. Now, there is no prep video for the final water video, and that's simply because I don't teach physics. I don't really understand the underpinnings of the Geisner wave formula. So what prep there is will be me rambling in that video. Alright, that said, let's move on to what tessellation is and what we need to consider with it. So, tessellation. As I said, what is it? Well, simply put, tessellation splits a mesh, the triangles in a mesh, into smaller triangles at runtime. Or, more simply, it adds more vertices for us to use. It increases the surface details of the mesh by adding these vertices in, and it allows for displacement. Now, there are other methods for displacement as well, but we won't be covering that in this series. Now, it requires DirectX 11. It occurs at runtime, and this can be very costly. It can slow down the render, it can slow down the frame rates, it can cause a whole bunch of other issues as well. So, you need to use tessellation with some caution. Alright, so what will we use it for? Well, as I mentioned, to make realistic waves. We'll do that in this and the next video, and to make our landscape more immersive, which we'll be doing in section 4b. There are multiple types of tessellation. Really, there are two, and those are flat and PN triangles. With regards to flat is simply what I described on the last slide. It adds more triangles. It doesn't do anything else. It just adds more triangles. By itself, these extra vertices or triangles don't matter. That's also true for PN triangles, slightly. By adjusting the world position of these vertices using normal maps or displacement maps or bump maps, we can create new surface details. And this is where we want to focus, is the adjusting of the world position, the vertices. This is how we're going to make the waves. This is how we're going to make the rocks and our textures for the rocks stand out. Now, PN triangles, well, really does the same above, does the same thing as flat, except that it takes into account the normal to create a smoothed subdivision of the triangles, so that the transition when we add more triangles in is a bit smoother. Typically, PN triangles you'll use for more complex surfaces. To work, this requires a mesh to have at least one smoothing group. And like flat, just adding in the vertices doesn't do anything. We need to adjust their world position. And we'll do so using, for the waves, the Geisner wave calculation. Alright, so tessellation is controlled by multiple things. One of those factors is the tessellation multiplier. So the multiplier states how much tessellation should occur on the mesh. So how many triangles should be added in. And there are two settings that control this. There's max displacement, which is in the details panel, and the tessellation multiplier, which is in the material output node. Now in reality, there's actually a third element to this, which I'll touch on in just a moment. So the multiplier runs a range of 0 to 1. Where 0 is 0% of the displacement and 1 is 100% of the displacement. So if we think about it, it is the multiplier times, or multiplied by, the max displacement. So if the max displacement is, say, 100, just picking a random number, and your multiplier is 0, then you're getting 0. If it's 0.5, then you're getting 50 of whatever that max displacement is, and so forth. We also then have the max displacement, which normally we don't need to look at it, but we can use it for finer control, for fixing displacement, cracks, and tearing. So we'll talk about cracks and tearing in a moment. But now, as I mentioned, there's really kind of a third thing. So in theory, this is limited by some of the things that are hard-coded into the engine. In newer versions of the engine, I believe 4.14 and greater, the hard-coded value is 15, and in older versions, it's 10. So technically, the multiplier can't go above this. Now, I mentioned cracks and tearing, so let's explore cracks and tearing a bit further. So one of the settings we have is crack-free. So when we're adding vertices to a mesh, then adjusting those vertices' world position, so we're creating surface detail, we can create tearing. So imagine you have two vertices, two dots right next to each other, and you adjust the world position of one by moving it to the left, and the other one by moving it to the right. You might end up creating a gap between those vertices where there is no face. And this is tearing or cracking. So this is where they don't touch and there's a seam or tear or a hard edge, a blank space between the two. Think about games you might have clipped through the floor because something isn't lining up correctly. Something like that. So we have this setting known as crack free. This is in the details panel of a material. And the setting aims at reducing tearing that can occur due to displacement. Now, a lot of people I've read online say this doesn't work. I've seen that in a lot of forums. They don't say much detail about why it doesn't work, and there could be many reasons. There could be issues with the mesh, there could be issues with the materials, issues with the settings. There are so many different issues, and yet I've never seen on any of these posts why they're having these problems. Like, they don't go into the details. So, in some cases, it simply just doesn't work. It doesn't do enough. You have to go in and do some changes yourself. But when you're running into issues with crack-free displacement, one, you need to check if the adjacency buffer is set in the mesh. This doesn't apply to our work. And potentially subdivide the mesh. And, you might need to do that for some of the things we're doing. You won't need to do that for the landscape, by the way. And then we have adaptive tessellation. Adaptive tessellation allows for us to adjust how the tessellation works based on the amount of screen space being taken up. If you remember in the last video, I talked about all the instructions that have to be done based on screen space and screen resolution. Tessellation is part of those calculations. So we can adjust what is tessellating based on how much screen space the item is taking up. So with adaptive tessellation disabled, again, remember this is in the details panel of a material, so you can just click it on or off. The multiplier will run between 1 and 15, which is the default of the newer version of the engine. If you're using an older version of the engine for some reason, it'll be 1 and 10. The multiplier is applied uniformly over the tessellated mesh. And this is the key part about non-adaptive tessellations, that word uniformly. And of course, we can work around this in other ways. And we will. With adaptive tessellation on, the multiplier is controlled partially by the camera location in the relative screen space. And this control ranges, again, 0 to 1, like a proportion, where 1 is closer to the camera, and we're getting 100% of the tessellation. And 0 is farther from the camera, and we're getting 0% of that tessellation. So again, the way this works is it's the adaptive range times the max multiplier. Now, we will use this, and we'll create our own adaptive element for the camera location as well. So we do that by thinking about how do we control tessellation. And we want to control tessellation because we don't want things to always tessellate, or we don't want the tessellation to occur for the entire thing and only the parts near us. And we do this because, well, objects that are far away, we don't always need them to tessellate. We need them to tessellate when we're near enough to see the surface details. We do not want to have all this calculations going on for vertice locations and displacement when we can't see it. It's a lot of overhead. So we want to control based on distance to make the system more performant. So what we can do is we can control when the tessellation starts to occur and how much the tessellation occurs based on the distance. So for this, we'll make a camera distance calculation function that we'll use for all our tessellation. Other things we might want to consider with control include, well, multipliers and GPU strain. So I've already talked about multipliers. I've talked about the fact there's a lot of overhead, and that's the GPU strain. So we could just stick a tessellation value in and leave it in as is. And to be fair, in some specific use cases, this is fine. However, in many cases where you're tessellating large objects like we are water and landscape, not so fine. And tessellation is not cheap. We can control how the multiplier is applied. And we'll be doing that using our material instances for both the water and the landscape, just to make things a bit smoother. We'll actually focus more on that with the landscape. Same with edges. In large mesh items with large tessellation, edges can tear, not align properly, do some weird overlapping, have some Z fighting. There's a whole bunch of issues that can come up. We can control the smoothness of the edges of large objects, and we'll actually do that with both the waves and with the landscape. So this smooths out how the tessellation works. All right, that covers everything that we need to talk about in this prep video. This video and this series have been brought to you by Patreon sponsors like Rian, Hanas, 1Vault10, and Quad Menson. If you want to help this channel out, please hit that like button down below or the subscribe and notify bell. And if you want to take your support a bit further, consider becoming a Patreon sponsor. All right, I look forward to seeing you in the tutorial proper, and I hope that you have a wonderful day.